have, well, I sort of wanted to bring all of those talks together and ask Chuck and Lauren about some of the requirements and testing that they're considering with cleaning their materials, and considering all the testing that Mary's test showed us, Mary's talk showed us, and what is possible and what's really necessary. What kind of priority does that receive when you're developing your materials? So Chuck or Lauren, if you have any.
Sure, I can jump in on that. It definitely informs us on how we decide on, what substrate we're actually going to pattern on, and also the materials we may use to bond it to the garment and actually the underlying garment. So that's been something we've been key to watch, and we do get informed by some of our customers on what their expectations are. Yeah.
So you mentioned in your talk that you had an external testing house test some of your samples, and did you follow a TCC test methodology or something else, or how did you approach that?
We followed a test methodology that one of our customers agreed to, that also was based on one of the local apparel companies here in Portland use.
Right, got it. Great.
So
there's a question, I think Ona from Jabal has a question.
Oh, I have a lot of questions actually, but I'll have to start somewhere. Maybe, I guess first of all, thank you everyone. I think those three presentations were super interesting. I was so excited to be able to follow those. So to Chuck first, I was wondering about some details about the testing you did. Like, you did the elongation and the resistance in elongation as well as washing. Did you do any combination of those two, like seeing if the elongation properties changed after washing or things like that? And then I guess another question to that is, like, did you test any of those structures to failure, and did you find kind of the limit values where they failed when it comes to elongation as well as maybe washing?
Yeah, in the washing, the structures were certainly getting stretched, twisted, and bent as they were being washed, because they were loaded in with I can't remember how many samples it was, plus some additional towels to fill out the load to the mass. We have tested to failure. Typically what happens to failure is the substrate fails. We had one substrate we used that actually tore, but there was a thin thread of the metal gel that was still there, even though it looked like the thing was completely torn apart. It still was conducting. So the usual failure mechanism is the underlying substrate, not the metal gel in those kind of cases.
Yeah, that's what I was thinking. Like, I would imagine like the metal gel could probably handle like moisture and somewhat, and then temperatures too, but then you kind of have to have the whole structure intact to have the functionality.
Yeah, I mean, one of the fun things that we've done initially with our partner in Europe is they were able to bond it onto some silicone, and we can stretch this about 300%. It starts off about 8 inches here, and I can get it up to about 36.
We can't see where your hands are going outside the screen, Chuck.
Yeah,
could be.
I'm going to have to do it like this. So yeah, this far.
Then maybe one more question to Chuck. I was wondering, what is the effect of like ambient temperature? Like, what kind of temperatures can the metal gel tolerate?
It's, as a liquid, it'll stay liquid down to below 10 degrees, minus 10. And it really depends on
Fahrenheit?
Centigrade.
Oh, okay. Oh yeah, of course, sorry.
Yeah. Sorry. And then we've tested it in a situation on some ceramics, and it was still conducting at 700 degrees C.
Okay.
So a little above where we'd probably use it in a textile.
Yeah. Thank you.
Nice questions, Ona. Thanks. It's really interesting. There's a question from Carmela in the chat. Carmela, do you want to ask that yourself, or should I throw that out there? I'll ask it for Carmela. This is for Chuck. You mentioned toxicity in your presentation. Can you elaborate a little bit more on that? And I was also wondering the same thing, sort of biocompatibility of the liquid metal.
Mm-hmm. Yeah, at this point, we haven't done any biocompatibility. We do know that the Galinstan alloy, the gallium, indium, and tin are RoHS compliant. And there's nothing about any of the other operations we do to make it into the gel that should put that at risk. We have had some other people ask about that, so it's pending that we would do some biocompatibility testing. That's probably in the future.
Great. Actually, while we're talking about the gel, I was wondering, and perhaps I'm misunderstanding the structure, but it's a liquid metal conductor in a channel. So if you squeeze it really hard, do you stop it from conducting?
Actually, if you squeeze it really hard, you got a pressure sensor.
Okay, so there's always some conductance in there.
Yeah. The resistance changes linearly as you stretch it or compress it. So that's one of the indicators you can use.
Cool. So I had how much more time? Oh, we've got some more time, so I had some more questions. Anybody in the audience
can
have
I
any
ask
questions?
a question?
Yes, please do. Go ahead.
Hi, Chuck. Really love the presentation. I was just curious on the pressure part. You said that as the pressure varies, the conductivity changes, so we can measure that. So I'm just wondering, have you had people use this as a microphone almost then, as a contact measurement, because it's so fluid and responsive?
Not as a microphone. That would be interesting. We've used it as and demonstrated as a pressure sensor, where we fold a series of traces of one over the other, and then as that gets displaced in the channel, you can monitor the change in resistance of the network.
I see. I was just kind of interested because it's like fluidic and almost looks similar to ferrofluid in a lot of ways, from what I've seen of those. Yeah, anyway, I was just curious. So have you done any frequency response studies on the changes to pressure?
Not in that realm, no. The frequency response we've done has been more in the RF.
I see. Okay, thank you, Chuck. I really love this. Yeah, are you open to small purchases, or how does it work?
Interesting question. Yeah. So what our business model is to license and design structures using the metal gel. We're not exactly a material supplier directly, but we certainly could work with you offline. So.
Okay. Thank you.
So we have a raised hand in the participant list from Salwa.
Yes, I have a question for Mary. You mentioned powder detergents are not really recommended. They are not good with products that have adhesives and glue. What kind of detergents or what kind of washing would you recommend for products which are made with a lot of adhesives and glue and things like that?
Yeah, that's a great question. And I should have qualified that, certain powders. And so we know we used Ariel powders in that same study. And they actually have those builder components that are meant to, bind to minerals like calcium. And so if you have, good quality powder like an Ariel powder, that may work. However, what we really do recommend are liquids. Liquids typically have, and because they also contain builders, are better at preventing the deposition of the minerals on these synthetic fibers.
Okay, thank you.
You're welcome.
So I'm going to go to Sarah Hoyt now, who's raising a hand.
Hey, thanks for the incredible presentations, y'all. I had a quick question for Chuck. You mentioned that the metal gel needed to be encapsulated, and I was wondering what formats and composition of encapsulation material have you found to be suitable?
Most plastics, specifically TPU, the thermoplastic polyurethane, is very adaptable for all the structures we've done. We've done a polyolefin material. Challenge with that is not a lot of things bond to it except itself. And silicones, this stretchy thing I was trying to show before was all silicone. But yeah, we're continuing to explore those different substrates.
Cool. And I had a second question, if I could double down, or should I get back in line?
Go for it. Go for it.
Okay. and this one was I'm sorry, for Lauren. You mentioned that currently your draw system, they're all that perfectly cylindrical profile. Have you or are you able to do non-cylindrical profiles with textures or any continuous non-cylindrical shapes?
Yeah. So the micrograph that I showed was definitely a cylindrical structure with kind of things inserted, but by no means are we limited to that shape. Basically, you know, whatever shape you can impart on your preform, that can be preserved in the fiber architecture as well. So we're doing quite a few rectangular things right now, and have an interest in doing some more complex kind of surface texturing and whatnot as well. So it really is a platform for kind of whatever you can dream up in terms of integrating different sort of structures at that level. Yeah.
Wonderful. Thank you so much.
Yep, you're welcome.
So Saha has been waiting patiently in the chat. Saha, did you want to ask your question, or would you like me to read it for you? Okay, I'm going to read it. So Chuck, you mentioned that the metal gel was knitted in a fabric. What is the gauge of the metal wire in American wire gauge?
Oh my goodness. I know the trace was 0.5 millimeter by about 6 inches. And the thickness of it is about 100 micron based on the thickness of the substrate we happen to use at that point. So okay. 0.5 millimeter by 0.1.
I'm sure that's possible to convert. And then there's a follow-up question about the metal gels being conductive in one direction. And I think this was when you were talking about the knitted structure, there were perhaps 2 layers. And so could you elaborate a little bit on that? Is that conductivity in one direction caused by 2 separate layers, or is it something magical going on?
No, there's nothing magical. I think what it might have happened is I might have been talking faster than I was reading. In the stack up, you try to orient traces in one direction on one layer and then on a different direction on the other layer, so you can actually have the crossing and make the circuitry a little more complex. It's kind of similar to one of the presenters earlier talking about it with the stitching. It's the same problem. We just solve it similar to how a printed circuit board does it.
Mm-hmm. Oh, okay. I think Carol was raising her hand earlier, but maybe it got tired. The icon got tired and went away. Carol, would you like to go ahead and ask a question?
Sure. Can you hear me?
Yes.
Okay, great. I have a couple of questions, and the first one is for Mary. And thanks so much, Mary, for a really interesting presentation. And I'm wondering if you can tell me, how do you use the Tide pods? Are you supposed to use those alone, or do you use those with Tide detergent? I've always wondered, and I can't really figure it out.
Oh, sure. So Tide pods are a laundry detergent. It's a liquid laundry detergent pack. And so it's highly concentrated. It's about 90% clean ingredients, 10% water. in a completely dissolvable film. And they are meant to be used as your laundry detergent for best results, because you know we all have to do our laundry, don't we? You always put the Tide Pod into the drum, no matter what type of washing machine you have, you know, unless it's the new GE machines that actually automatically dispense Tide Pods. You place them into the drum, and then you place your clothing items on top of the Tide Pod, and that is your laundry detergent.
Because I've been using both. I would add the pod in addition to the, what do you call it, the liquid laundry detergent. So I was just really overdoing it. Is that correct?
Probably you were. But it's to dose for the size of your load. So as Meg said, I really don't know, Meg, who wants to do 36 bath towels in one load? 3 towels to do one load. But the more items you have in that drum, the more soil you have, the more detergent you need to do. And so, you know, I advise everyone to look on the back of your Tide Pods package, or look on the back of, you know, whatever detergent you're using, a liquid or powder, and really determine, based on the size of the load, the amount of soil in the load, that you are dosing appropriately.
Thank you. I have another question, and it's for Lauren. And Lauren, thanks for the great presentation. And I'm wondering, what is the finest diameter that can be made of the functional fibers where they are still functional?
Yeah, so, and it really depends on what the function you're imparting is. So we've done stuff down to about just under 100 microns in diameter. Those types of fibers, we were looking at engineering the spectral properties. So there was no electronic functionality in those, but they did have additional functionality beyond the traditional fiber. In terms of electronics, the smallest we've got down to is 300 by 100 microns. So like a rectangular fiber in that sense, and that has like a 4-wire bus inside of it that we can then start to bring I2C kind of functionality to it. So yeah, it kind of depends on what the functionality is, but for electronics, it's about that 300 by 100 micron diameter.
Okay, cool. And so you said during your presentation that, and if I followed you correctly, that your targeted size was 100 microns in diameter. Is that correct? For what you were considering a yarn, which would have been like the monofilament?
Yeah,
is that true?
Yep. So that is what we're targeting in terms of maintaining, especially for that specific example. If your kind of host fabric is 260 denier multi-filament traditional yarn, 100 diameter smart fiber would be, you would need that in order to kind of maintain the flexibility and the hand of that original fabric. Depending on what your electronic functionality is, that might be sufficient. We've run into applications that are pretty power hungry and actually need a little larger, higher gauge wire and whatnot in order to have the function we need. So it's kind of a balance between understanding, you know, what the electronic requirements are, but also wrapping in these mechanical requirements to make sure our fabric still behaves like a fabric. Does that answer your question?
Yes, thank you. And can you successfully weave and knit, you know, the higher diameter fibers without them breaking and have them still continue to be fully functional in the finished fabric?
Yeah, so we can definitely get the higher diameter fibers in there, you know, closer to 1 millimeter. And those tend to have higher reliability in terms of the wash testing and things that we've done, or FO has also done. That being said, you'll notice that they behave less like a traditional fabric, depending on how much you put in there, which was kind of seen in some of those videos I hope you saw from the talk. So depending on what your application is and if that's acceptable, then that's great. But if not, you know, then we need to kind of think more about the design of that fiber and then, you know, how to meet the requirements necessary to make it look and feel like a fabric.
So the black fiber, I mean the black fabrics that you would do in like the crush tests with your hand.
Yeah.
So what were those made from exactly? What were they made from?
So the base yarn was a nylon multifilament. That was 1,000 denier weight for those. And then we put in nylon monofilaments inside of that to kind of be a surrogate representative of what our smart fibers would be.
So why didn't you just use your smart fibers to make any of those fabrics if you can successfully weave and knit them? I was just kind of curious why you went to all that trouble.
And so that, and mostly that's just due to the scale of our parametric study. You know, we had like 53 some samples. It was hundreds of yards of fabric. And so having easier access in order to produce that much fabric, solid monofilaments of a polymer were easier to access and, you know, fabricate at that scale, let's say, right? To be able to integrate these integrate into the fabrics quickly. Along with all this fabric testing we're also doing some testing of the yarn level, comparing now, these monofilament surrogate fibers to the various functional fibers that we make, so that we can extend our results from the parametric study to specific functional fibers, as you mentioned.
And what's the draw rate on those fibers?
So we can draw. You're interested in kind of the scalability and like how much we can produce? Is that?
Yeah, just right now, whatever you have your setup at Lincoln Labs, what's your draw
so we
rate?
Can do,
day or something?
Yep, if we start with like a preform that's about a foot in length, that can end up being about 300 yards of functional fiber. And that usually takes about 2 to 3 hours to draw that.
Okay, cool, great. Sounds like there's been some progress. Thanks so much. Thank you.
I have another question for Lauren in the chat. I'm not sure if you'll be able to answer this, but is the Lincoln Laboratory developing any fabric in collaboration with others? Are you allowed to tell us about anything like that?
Yeah, so I can tell you that we work with other people for sure.
Right.
The majority of our projects are government funded directly, and so we're doing various projects for the different services that need it. In parallel, though, we also are open to doing like STTRs, SBIRs, that kind of work with commercial companies. And so maybe this isn't the heart of the question is asking what we're working on, but I can't elaborate too much on the different projects, but we'll say that we have a variety of vehicles with work with others. So if you're interested in working with us, yeah, shoot me an email and we can figure out if that's possible.
That might be what the person is interested in asking. Great, thank you. Another one from the chat. This is Marianne McDougall, says that wool has antimicrobial qualities and is very popular in current activewear base layers. If we're combining e-textiles with wool, does Mary have any cleaning suggestions or thoughts on wool? Some people do not launder wool.
Yes, so great question. And the answer is, if you think back to my slide where I showed, dead skin cells, the sebum, the sweat, I am the sweat lady according to Megan, and so, and the salt. And so, yes, you do have to wash wool, especially if you're using it as activewear. So it may not noticeably sweat because it has antimicrobial properties, but oxidation over time will cause the breakdown of soils. They will smell over time, but also too, we've had conversations with other folks where they become mealy, where you have the accumulation of the oils, the dead skin, the salt, of course. And so, the feel of it, the aesthetics of it really will decline over time. Now, some detergents, like most of the Premier Tide detergents, do contain proteases, which could potentially over time degrade the wool, since they are protein fibers. And so we would recommend, if it's an item that needs multiple washings, possibly using something like a Tide Simply that does not have enzymes versus say like, a Tide Original or the Tide Pods, which do. But yes, you really should, even though they don't smell, as per my other slide, they may not look like they're dirty, they may not smell as if they're dirty, but yes.
No, we know too much now. We know too much, thanks to you, Mary.
Unlearn that. I've had people shower, go home, wash all their clothes again. So yes.
Yeah. A couple of people have their hands up. Sarah Hoyt, would you like to ask your question?
Oh, I'm so sorry. I just failed to press the lower hand button.
Okay.
Thanks, y'all. Sorry.
In that case, I'll go to Vignesh.
Hi. Two quick questions. First, about the washing part. I was just wondering, given the COVID circumstance, do you have any suggestions for people with the added context of COVID? Is there any special care we need to take for clothing? And can we apply some of those into our training? So do you suggest any alcohol pre-rubs or something like that? So just curious what the standard advice is right now.
So the CDC has advice posted on their website, and basically one needs to understand that respiratory viruses are envelope viruses. That means that they're really wimpy and that they are very susceptible to being destroyed. by surfactants found in common laundry detergents. And so if you're talking about respiratory viruses, the viruses that cause COVID-19, influenza, and the cold, as we're now entering into cold flu season, using your regular laundry process with special precautions is really all you need to keep your family and yourself safe. And so what those include is, if you're a healthy family, just, washing even on cold water and so on. But it is important, because our soiled laundry has microbes on it, that as we, handle soiled laundry, that we wash our hands. As we place them into the washing machine, you wash your hands. When you transfer from the washing machine to the dryer, you wash your hands again. And then after that, the risk in a healthy family is extremely low of getting sick from laundry. If you think someone in your household has a respiratory virus, so including COVID-19, flu, and a cold, then what we have is special handling precautions. You don't want the virus to become airborne, so you don't shake the laundry. You wear gloves if you can as you're handling the laundry. You can wash the laundry with other family members' clothes, and just wash them, ideally with a high quality laundry detergent, because the surfactants in there will be more effective against those viruses. In warm water if possible. Again, wash your hands after handling that laundry. After transferring it to the dryer, wash, dry in a warm dryer completely. And that's basically what you need to do. Now, stomach flu is an enteric virus, and that's a non-envelope virus, and that's actually very hardy. And so if you have like vomiting and diarrhea, that means you have some sort of enteric bug, a stomach ailment. In that case, you take the special precautions using gloves and so on. But in that case, we do suggest that you add a laundry sanitizer. You wash in the hot cycle, that you dry in the hot cycle. And you may want to use a disinfectant like bleach, but make sure that your clothes, and many are not, particularly ones with synthetic fibers, they can be washed safely with the chlorine bleach. Otherwise, we recommend that you use a sanitizer in addition to a really good quality detergent. And taking those precautions should keep you safe.
That I think common for everyone, but also particularly for me as we are going into the research season following year. Anyway, thank you. Additionally, second question, it was to you, Lauren. Real love the technology, what you guys are building. I was just curious if you've looked into doing embroidery with the yarn or thread which you make.
Yeah. So I mean, the holy grail is being able to weave this or knit this directly into a fabric, right, and have that seamless integration. For some applications, we find that we need a little beefier wire. We need to be a little larger to have the functionality we want to impart. And for those applications, embroidery or kind of post-fabric integration rather than into the fabric, directly into the fabric itself, but kind of on the surface, we're considering those types of applications for that.
I see, but mechanically, can I'm just wondering, is it hard enough to stand the forces as it's embroidering? I was just curious on that.
Yeah, so that's a good question. I can get back to you with more details, but AFOA headquarters has done a more extensive investigation into kind of seeing how these fibers stand up to various industrial processes. Often they've found that for a lot of things, we may need to kind of adjust the speed or the pressure forces or whatnot in order to get our fibers to integrate. So there are some tweaks that need to be done. By no means is it, directly just swap it in for a traditional fiber and you're fine. But I can follow up with you on that. And if I was talking with Fo a little more about it.
Definitely. Yep. Because in our lab, we do the technical embroidery and we're slowly getting into it. We're not there yet, but definitely I think we're constantly looking for new fiber and great. So thank you.
I can follow up with you. Yeah.
Thank you.
Awesome. So I've got a couple more questions in the chat. Here's one from Murnell. It's for Chuck. And Chuck, I hope that you can understand this question. I'm going to read it out and let's see if you can see what's being asked here. From the via layer, which was shown in the stack-up picture, how and why only one via layer would work for the through-hole vias? And Murnell, if you want to explain this question a little bit. Chuck, do you?
I can start answering. I was just going to give him an opportunity to
Oh, okay, sure.
expand. So in this case, we only had 2 trace layers that we needed to interconnect. And so we can just with one via layer be able to, at the right places, transition the trace from the first to the second trace layer. So it's relatively simple in that regard. Unlike a printed circuit board would have a hole drilled all the way through. We don't have to do that. We just need to make the ohmic contact.
Great. And I have a second question for you, Chuck, from Bijal. How exactly is the encapsulated metal gel connecting to the components if not soldering? Panasonic material which bonds them uses some sort of glue, or are you at liberty to answer this question?
Oh yeah. It's the properties of the Panasonic material are quite tacky, and what we on that layer we create windows that look just like the LAN pattern you'd see on a printed circuit board, and it matches the footprint of the device we're putting down. We put it down and press it, and then as we cure it, it seals around the opening, so we get a seal that finishes the enclosure of the metal gel, but still we get an ohmic contact from the trace to the pad to the device.
Oh, great. That's really clear. Awesome. Ona has her hand up, but I'm just going to ask one more question from Vignesh to Chuck while I have you, Chuck. Can you design liquid metal boards in standard PCB design software?
Actually, yes, we do. The only thing is your symbol has to be a little bit different because our LAN patterns are considerably tighter than what you would have on a board that you do with SMT reflow.
So you make your own library?
Yeah, we have a library of LAN patterns, part of our DFM, designed for manufacturability.
Great. Ona, would you like to ask your question?
Yes. First question, I have 2 questions, one for Chuck and one for Mary. So maybe Chuck first. The layers that you use to encapsulate the gel, is there kind of a maximum amount of layers you can do? And then individual layer thickness, what is the minimum you can do? I'm kind of looking for like comfort factors here, because I think if you start layering things up, it's gonna get kind of stiff and heavy.
Yeah, I mean, typically it depends on the design, on how many layers we need to actually physically interconnect the devices. If you're making a simple stretch sensor, we can do that in 3 layers. And it's pretty sensitive on a garment. You can't hide a breath from it. So it's been an interesting exercise working with some people on that. But really the layers typically are around the 100 micron. We haven't tried to push it to other thicknesses. We had to actually go thicker if we needed to carry higher currents or have a longer trace. So that's been one option that we have to deal with. And looking at silicones is kind of a fun area right now because they're far more stretchy than the TPU, although we've got some pretty good elongations. And so we're playing with that right now.
Actually, I have a follow-up question. Then about like the actual layers would work as like, would you say they would work as like barrier towards mechanical stress, also keeping the gel in place, but also they're like insulating electronically from the kind of environment?
It is a dielectric, so it does provide insulation between the traces, and we have to maintain certain minimum widths so that we have the integrity of the circuit, you know, as it gets stressed. So.
Yeah. Okay. And then my second question was for Mary. Do you see like detergent accumulating on the products or on the fabrics as a problem? Like if you wash it multiple times and then you end up having some residues of the detergent itself and then causing issues with the textiles?
So in typical detergents, that's why I say it's so important to dose appropriately for the size of your load and the soil of your load, and to help prevent actually carryover from the laundry detergent. What we see more often than not is that most people underdose, and so it's the carryover of the soils, or if they use, you know, a bargain detergent, it's the carryover of these body soils that really cause problems with odors and discoloration and things like that. With respect to e-textiles, we've done some work, but right now we haven't published that work yet, so we really can't share the results of that. But what we do know is, you know, as we talked about with certain powder detergents, that they can interfere with adhesives, with the integrity, you know, of components. But I unfortunately can't share more than that. Hey, but just to draw everyone's attention to that as well, I just put down a link. So I was just notified by the University of Arizona for folks who were wondering, because we all have, you know, we all wash clothes and we all have families, how to keep your family safe, you know, during the pandemic and so on. So they have some really great detailed Q&A that we actually helped to develop. In addition to the laundry experts, Chuck Gerba, Dr. Germ at the University of Arizona. And so the link is right there. And so hopefully Chris or Meg, you can also send that out to the broader membership. I see that we know we've lost some people as the time has gone on. So thank you. And Una, did I answer your question?
Yeah, you did. Thank you.
Super. Thank you.
Great. That's all the questions. Well, I have so many more, but we're over time, and that was an awesome session. Super interesting. Thanks everybody so much for speaking, and also for the great questions from the audience. I'm going to hand it back to Chris in case he has any IPC announcements for tomorrow's sessions or anything else. But thank you guys. That was really, really interesting.